Yeah, so I will start the recording. It's my really big pleasure to present you all Olga Paris-Romaskevich, who is a mathematician, in France,
Marseille.
France, yeah, exactly, in Tenerife. And there is actually a long history how we got to know each other. We both were together in the same university, in Moscow University, and then afterwards we also kept connection after that, and we're discussing together about some communication projects. And for the viewers, thank you for coming.
Okay, thank you very much, Luba, for inviting me to speak here. If people who are present can turn on their videos, I will be very happy. I mean, only if you want, because in this case, I feel I'm not speaking to myself. Hello, everybody. So I'm a mathematician, as Luba said, and I'm also interested in science popularization and connections of outreach with storytelling, because I think like the way we learn, we can't just learn all the information on Wikipedia and the way it's structured on there. So we need to have some emotional connection with the subject we are learning. That's how our brain works. So I think storytelling got this very right. From a long tradition of storytelling, I think started when people started telling stories to their children, and it's been a very long time. And yeah, I'm interested how to explain science and mathematics in particular through stories and through connection to culture. And today I wanted to tell you about a project. In some sense, it's my first big popularization project. We did it with my two friends when we were three of us students, graded students in Lyon, in École Normale Supérieure de Lyon in France. So now Valentin, he's teaching mathematics and doing some acting. I think he's also writing some play on Newton. And Marie, she's a mathematical storyteller and writer. She writes story tales for children with the mathematics inside them. So this project, it's called Mathematics of the Sky, and it's a project of a virtual exhibition of a site which contains information on the mathematics of the sky. It's more about celestial mechanics and the three-body problem. And I will tell more about the story of this project and the content, mathematical content of this project a little bit, and just share to you how it went. So what is Mathematics of the Sky? As I said, it's a website. It's in French. We don't have any other version, even though it could be maybe interesting to translate it in English or in Russian or any other language. The site has been launched in 2018. And as I said, the mathematics is centered about a so-called three-body problem. It's a problem, the three bodies in the problem are three celestial bodies. You can think, for example, about an Earth, a moon, and a satellite which is circling around the Earth, and we want to circling or moving on some trajectory around the Earth, and we want to stabilize it or move it in some particular way. The three-body problem is a mathematical equation, if you want, that describes the movement of three bodies with gravitational forces between them. And we wanted to share the mathematics of this problem with general public because it's beautiful mathematics. And we also wanted to connect the mathematics with the culture of this problem, the history, but also literature, and kind of mix mathematics with different media and different areas of human knowledge. We were also a lot encouraged by our supervisor, we have all three of us, we have the same supervisor. So it was a fun time because all three of us were writing their PhD thesis, and at the same moment we were working on this project. Maybe I should mention that Marie L'Huissier, who is on the photo in the green t-shirt, she also, her thesis was very, very special because it's the first thesis in France which was connecting research in mathematics and outreach, science popularization. And her thesis was on the Threebody problem, the research part that I want to tell about, and part of how to share mathematics with the general public. And it's crazy that we had to wait till 2017 to have the first PhD thesis on this subject, and hopefully there will be much more in the future. It was not as easy administratively to kind of create this kind of opportunity. But hopefully once the first step is done, the others follow more easily. And so this exhibition had some support in our community, mathematical community. It has received the coup de coeur, like heart prize of the jury of the D'Alembert Prize. It's a prize that is given by French Mathematical Society to initiatives in outreach in mathematics. So let me tell you about how the project started, how we conceived it. So it in ENS de Lyon, in this school, we in our graduate school, there was so-called junior laboratories. These are laboratories that offer to groups of PhD students to work on their projects with their original idea, and they supported financially to some small amount, some not so small amount. We had 6,000 euros of support for our project given by the school, and the laboratory for which we applied in 2015 was a special collaboration of this school, ENS de Lyon, with the museum, Musée des Confluences, which really was just opening in the moment this collaboration started. So it was a very interesting experience because once we signed the contract of working with the museum was not yet officially even opened. You couldn't go inside the museum. So it was really a start for the museum, which complicated some things, by the way, but it was very interesting to work with them. And on the pictures on the left, you see ENS de Lyon, the place we studied. And on the right, you see this building of Musée des Confluences. It's a very famous building in Lyon for many reasons, for its architecture, for the fact that its confluence means meeting of two rivers, the fact that it's on the end of the island between two rivers, Rhône and Saône. And it's also, it has kind of bad reputation in Lyon for the time it took to be constructed. And so these two places are very nearby. And the goal of this laboratory was to create scientific collaborations between the school and the museum. And I think some of them continue this year, now. And in the beginning, we wanted to create a real exhibition inside the museum, but I think we were very naive, which is good sometimes. But the museum staff explained to us that it's very hard to make an exhibition with the budget we had. More or less, if you have one thing to put in the museum, it can even, like, you want to put a plastic cube in the museum, it can even cost more because you just need to put the good lighting, for example, lights, and it will be already all of your budget. So estimation of the price of the exhibition was not very well calculated. So we decided to do a site. So all the material we conceived together, the three of us. There are different media, I will speak about this, and we spent most of all the money was paid to illustrator who did several pictures for the site. She's a comic book illustrator with Science Go. She's more she's illustrating scientific books or comic books with some scientific content, and a web designer, Bertrand Paris, but now he has the same name as myself. and they helped us with the visual aesthetics of the exhibition, which was important for us because we understood that the site which is not beautiful, it's hard to stay a long time on it, and we wanted people to stay and to read the materials. And we did several presentations in the museum of our exhibition. So if you want to discover more, maybe after the talk of the site, you just have to go to the link I give here, cielmmlyon.fr. MME, it's the House of Mathematics and Informatics. It's a wonderful place in Lyon, which is kind of a center of outreach in mathematics in Lyon. So let me tell quickly on the mathematical part. So as I said, the three-body problem models movement of three objects in a gravitational interaction in the sky. Any objects you take will have the same interaction. This is one can say Newton's genius or nature genius, that if you put three apples in the sky, they will also follow the gravitational motion, following the same law. So but the three poles which are interested for engineers and astronomers are Earth, Moon, Satellite, or Sun, Jupiter, Earth, the three poles of bodies. Jupiter because it's the biggest planet in the solar system. It has the biggest weight after the Sun. And this three-body problem is, of course, a little bit more complexified version of a two-body problem, a Kepler problem. If you have just the Sun and the Earth and nothing else in the world, the Earth and the Sun will turn on two ellipses, one around another. But since the Sun is so big, you can almost say that Sun is not moving, and the Earth is moving around the Sun on the ellipse with a foci in the with the Sun in one of the foci of this ellipse. And you see the trajectories of the two-body problem and the three-body problem, and you see that if I add a little violet third body, its trajectory may be very, very complicated. So you make a simple perturbation of the two-body problem, which is a very simple problem in some sense, in some precise mathematical sense, and you get crazy behavior. You can, if you, it's what we call in mathematics chaotic behavior. There are many, many different variants of behaviors, and if you change a little bit initial conditions, the behavior will change completely, like what is known as butterfly effect. And you also see a picture how we were filming some videos for our site. We didn't have all these formulas, God forbid, on the popularization project. We actually almost completely got out any formula from the project. And if formulas persisted, we tried to explain them. We took lots of time to explain them.
But you're showing the simulations, right? You were, or it was mostly the results of the...
Yeah, we had very different medias. We had simulations, and the site has around 30 different simulations, numerical simulations of trajectories of a three-body problem. Of course, if you put the bodies of you have many parameters. You can change the masses of the objects, you can change their positions, their velocities. So we had different examples of what can happen. So we had indeed the numerical simulations. We had some videos with explanations of laws of motion. For example, we have a video explaining what F equals ma really means and things like this. So we did have different kind of differently directed explanations of the same thing, maybe not explanations, but ideas or illustrations of the same mathematical concept. There are like three heroes on our site. If we want to speak about representation of science, we have chosen Kepler, Newton, and Poincaré as three scientists who made very important developments in the understanding of the three-body problem. Of course, it's no way complete. It's like saying maybe that literature is reduced to Homer, Shakespeare, and Nabokov, and like it's completely not true, but there is something. There is something. I mean, these are really big revolutions in the way of seeing the problem. Kepler said that actually Earth seems to move on an ellipse. Actually, he was speaking about Mercury mostly, but that there is an ellipse in the story. And for a very, very long time, people tried to look at the trajectories of the planets as approximations of circles or sums of circles. Because I think it's maybe something which is coming from ancient Greece, that the circle is a perfect shape, and it's very hard to imagine that there are other shapes than circles or the sums of circles. And anything is a sum of circles because of Fourier, but looking at the trajectories in an ellipse is a better approach. And it was really difficult, revolutionary step, especially for Kepler and for the religion at the time, because there was always the question, what is in the other foci? If you move on the elliptic trajectory, what is in the, in one foci you have a sun, but in the other foci there is nothing. How can it be? These duality things are very hard to acknowledge when religion is very present. And then Newton, of course, introduced his laws of gravitation, and it was amazing because this is kind of solving the inverse problem, finding an equation, knowing the solutions. Usually we have to find a solution in school, like we have some x squared equals 1, and we have to find solutions. But here we have solutions. We know what trajectories planets draw in the sky, and we need to find the equations. And Poincaré proposed a qualitative study of the problem, of the three-body problem, saying that three-body problem, okay, it's very complicated. We won't be able actually to find the solutions of the equations of motion, but we can find some other geometric and dynamical qualitative study of the problem. We don't need to solve the problem to understand the problem, to solve the equation, to understand what this equation tells us. And what we wanted to say, especially at that, these three scientists and many other scientists, to show that the humanity of science, that there are not only great minds, but that there are also humans. For example, here I put some French citations. Actually, they're initially in English, but I didn't have time to translate it. It's from the journal of Newton. He's writing like some bad things he did for himself. He says, like, I have eaten an apple in your house. It's like in the house of God. So he has eaten an apple in the church, for example, and he's not good for this. And he hit his sister, and he wanted death for some other people and for himself. So these kind of things, we show it on the site, and we also speak a lot about Kepler, who was also quite a character, to show that scientists are not just the theorems, and we, all three of us, believe that it's very important to share that. And so for our goals, we were thinking about the public of the museum, Musée de Confluence, which is mostly adults and school students. It's like a family museum. People often go with their family. And we were thinking about curious public that love to learn, but that don't necessarily are interested in mathematics. And we wanted to show them, to propose them kind of a promenade or a walk through this area of our research of celestial mechanics, because all three of us were working in dynamical system, and celestial mechanics is the three-body problem is actually the first dynamical system which was studied with modern dynamical systems method, because Poincaré invented dynamical systems. And we wanted to share modern research and its stories and its ideas, but at the same time not be repulsive to people who don't like mathematics maybe. So it was quite a challenge, because at the same time we wanted it to be a mathematical exhibition, and at the same time we wanted not to be too scary to people. We wanted, our intention, it's something going a little bit, a consequence of the goal. We wanted to leave lots of liberty to our visitor. We didn't want to see the content of the exhibition as some linear accumulation of knowledge, and more like a vagabond walk. We wanted them to go at their pace, to jump from one part to another. but at the same time, we wanted to propose rich and complicated, complex content, mathematical content. So the forms that which was also in some way a conclusion of intentions and goals was that, as I said, aesthetics was important for us, and we wanted to propose a diversity of media. We did many different videos, we did a quiz, we inserted many pictures, art reproductions, citations of different scientists. We also invited some scientists to write something on their research with relation to more classical celestial dynamics ideas. We showed numerical simulations, and we had some audio extracts from the books, etc. And as I said, we didn't have almost no formulas in our site. So the structure is very simple. So we had 2 years to do it. We were 3 graduate students. We didn't have much budget. So the site is very simple. There are 2 parts on the site. And the first is called 2 stars, face to face. It's more classical mathematics, like mathematics of 17th century. There are discoveries of Kepler and Newton, and more like we're more concentrated on the two-body problem. And the second part is chaotic dynamics. It's like modern dynamics, modern mathematics, very alive today, with many complicated concepts like Berghoff sections and three-body problem. And we have these 2 parts. Each part has 9 chapters. You see that on this picture. Or you can click on any of the 9 chapters. And for example, here on the left, you have an example of 1 chapter, which is paradox of attraction, in which we explain why doesn't the Earth fall on the sun, even though the forces are pointing one to another. It's you should ask yourself, do I really understand this? It's a very important thing. I mean, that's why we are alive, right? So in total, we have 10,000 words of text, which is repartitioned on the site. You see that we don't have very long passages of text. We have 1 hour of video content, which is mostly interviews and animations, and some other contents. So if one would want to visit the entire exhibition, they would spend around 3 hours. So of course, we didn't expect that. So to conclude, I want to say that what was especially important to us was to share through representations, through real content on the site, 4 ideas which are obvious for people who are scientists, but sometimes are not as clear for general public, a little bit far from science, that mathematics is a part of culture. It's not separated from the culture. It was evolving with it. That mathematicians are human with their feelings, thoughts, lives. That mathematics is alive as a science. That there are still open questions and new answers appearing each day. And the mathematics is personal. That everybody understands in their way, and that mathematics is accessible to anyone, and that the people should find the ways that they understand things and think on this. Maybe some people understand better through video or through text or through audio or through a very precise explanation or through an idea, etc. We tried to go from different ways to the same idea. So of course, I have no idea on the impact of this exhibition, and it was actually not our goal as science communicators. We just think we grew a lot with Marie and Valentin by doing this project, because it was the first project, collaborative project. So I think it's also useful for people who do this site to do this kind of things, because it teaches you how to be a popularizator, even though I don't really like this word. Yeah, I think it was very, very instructive for us. And Marie, in her thesis, she worked on the ways how she was really doing research on how you can share mathematics with people. And she did a study on a small focus group of 10 people trying to understand how they worked through the site. And if you want to read it in French, but in her thesis, she gives more information on that. And I think an interesting thing how the exhibition can still be used today, and it's as a pedagogical tool in schools. For example, we did several presentations in schools where we proposed to students to go to the site, to wander around the site, and then to discuss. And it was very successful, I think, but we were there to discuss after. So if there is no scientist behind, I think it's important to give to the teachers the tools to propose this exhibition. So maybe to give some more detailed explanation of the structure of the site to the teachers so that they know, because when you are on the site, it's not as easy to recover the structure behind it if you don't know really very well the material. So just to finish, this project was finished in 2018, but this year it kind of is coming back in a new form because we have a mathematical calendar for the next year. Hopefully it will be better than this one. Maybe it's not as difficult. And this mathematical calendar, it's a long initiative of Anna Rechtman, who is a mathematician. She started it in Mexico. Maybe you can invite her once she can tell you about this project. It's a very ambitious project and going pretty well. And so on the calendar, I actually have it here. The idea is that you have each month, you have a picture, you have a text, and you have a problem, mathematical problem, one problem per day, except for the weekends, no problem on weekends. And you can put it in your house and solve problems. So this is the thing which is now in libraries, in French libraries, but also can be bought on any internet shop you think of. And yeah, just to finish, I'm already completely out of time, I think, but I will still.
It's fine.
Fine, okay. Let just me share that what I'm doing now, because 2018 is past, and I'm now in this new project, which is more in the stage of elaboration, and the idea is to it's a scientific journalism project, I think, and with a little bit art inclination. We are doing it with Bertrand Paris-Romaskevich, and the idea is to take a train through Russia, through 10 different cities, and speak with Russian women who contribute to research in mathematics in Russia. I formulated it like this because there are not only researchers, but also teachers, secretaries, administrative staff, because when I was in Russia and here in France, I also think that it's important to say thank you for these people who are in the wheels of the system, but you never have the opportunity to thank them, and it's important and to show how much work they actually do for the community. And this project, hopefully the tour itself will be in the spring of 2021, or maybe later. It will depend on coronavirus situation, of course, but it will open in the International Congress of Mathematicians in St. Petersburg in 2022. I don't know how if everybody knows what ICM is, but it's the biggest mathematical conference in the world. It's each 4 years, and Fields medals are given there. So Nobel prizes in mathematics are given there. So it's a big mathematical conference. There are thousands of people there, even though usual mathematical conference will be more like 50 or 60 people, maybe 100 for a big one. So for now, I'm now in France, and I'm kind of training for this project here in France by doing interviews with people I think are doing a lot for the community, and they just interest me actually. So I did one interview with my friend Marie about her mathematical tales, and one interview with Olga Kravchenko, who is, as myself, Olga, mathematician, Russian, and living in Lyon. but as you can guess, we are not the same. And it was very interesting to speak with her about her math. She's doing research in mathematics, in algebra. And I hope to continue doing these interviews for now in France, and then we'll see how it goes, if it becomes its own project, you know, like when you train for some project, sometimes you end up doing another project. So we'll see. For now, I'm just doing these interviews. They are two of them are already published on Image de Math. It's a wonderful site about mathematics in French. If you read French, I really recommend the site. It's very rich, and it started being translated in different languages. I think there is a big translation team for Spanish language. Maybe there is a translation team for English, I don't know. So this is a thing I'm working on now. So I will stop here. If you have questions, I will be very happy to answer or discuss something on this topic and around.
Thank you, Olga. Me personally, I have several questions, so I could ask maybe. If you don't mind. So
yes,
actually, I have a question about this project, because I know that you already did this Trans-Siberian train, right? And you did a big journey. But so your idea would be to find people occasionally there, or actually find them before you go? Because
yeah, so we have, yes, so we have support from Committee for Women in Mathematics, which is a very respected international organization. So I wouldn't risk going like randomly, even though it could be interesting. I agree. But I have already chosen heroines, I call them heroines of the exhibition, and I have contacted them, and 9 of 10 already said yes, and I have to rewrite to the last one. So yeah, I have planned on that, because I also wanted to not to have, it's impossible to have representative something that represents faithfully women in mathematics in Russia. So I also was guided by my personal interest. So yeah, I have chosen heroines. So you see on the map, you see the cities I have chosen. I was also interested in cities, because I wanted to have something like more deep to the east, and also to see the west. So I have chosen big cities. Yes.
Like Novosibirsk and
yes, Novosibirsk, Irkutsk, Khabarovsk, Yekaterinburg, Moscow, St. Petersburg, of course, but also Kazan, Samara, Nizhny Novgorod. Yes, actually there are 9 cities, because I couldn't resist speaking to 2 people in Moscow because it was too hard to choose. So yeah, I planned this in advance, and of course it will be complicated. I know it already, to kind of choose the good dates and to have a very precise plan of how you move through Russia. And indeed, we always did this trip for Bertrand because for our personal interest. And for me, it's also important that we already did this trip, actually, because of course, making this trip is in itself a dream. So I'm happy that I already did it. So now for me, it's also saying that this project is important for me, and I'm not doing it to make a second ride on the Trans-Siberian, even though I'm also happy to do it, but also because it's important to see Russia through this lens. And it's of course a feminist project, but it's also a mathematical project. For me, it's very interesting because I love mathematics, and I know mathematics to some extent. So for me, it's very interesting to see my country that I miss a lot through this lens, since I'm working in France for already six years. And yeah, it will be interesting. And I'm also following a lot of political situation in Russia. So I think also seeing these big cities maybe also give some feel of how Russia feels in 2021.
Yes, and I was just managing the question in the chat but just to that question, because I know that Marina Ignacio, she also told me about this big congress, right, of mathematics, which will be happening also in Russia, in St. Petersburg, right? So that would be incredible, actually, to see your project also maybe contributing to that celebration. right? Yeah.
Yes, exactly. I think it's important. I hope it will be presented somewhere in the place where people who come to the Congress can really see. And yeah, it's important for me, as you certainly know, but maybe somebody doesn't know. We have only one Fields medalist who is a woman. She actually died in 2017, Maria Mirzakhani, unfortunately. So there are no Fields medalists in mathematics alive who are women, and like the first woman who got a Fields medal was in 2017, which is a great shame. I mean, it's very good we started, but we should have started earlier. And I think it's important to remind of this aspect of equality, which is important. And yeah, I'm happy that this exhibition will be at the ICM. Yeah. And there is also Committee for Women in Mathematics. It will be the second year they organize a satellite conference for one day, which is called Women in Mathematics. It's now the partner of ICM, so there is always a Women in Mathematics conference as a satellite of ICM.
Yes, thank you.